Hello, this is Jake Roos. I work for Greater Wellington Regional Council and I'm here today to demonstrate the Wellington Region 2050 emissions calculator. Now this tool allows you to forecast the emissions from the Wellington region under different circumstances. There's a whole other video explaining all the ins and outs of how it was developed and all of the background data. My task today is to show you how it can be used to actually explore some of the scenarios and what some of those scenarios look like. So go to the website there, which is gwrc.2050calculator.nz, or any of the aliases. They all lead back to here. And then we click Launch the Calculator. Now there's this little promo screen that explains, gives a little bit of background about the calculator. You can read that. I'm going to explain it to you so you don't need to read that right now. So here we have the projected emissions from 2010. Obviously there's the past we know about. There's also into the future as well to 2050 from this point where we're at now, which is near 2020. And you can see different categories of emissions here: land use change in forestry, waste, agriculture, solvents and other product use, fuel combustion, which includes all transport, and something called bioenergy credit. I won't bother explaining what bioenergy credit is right now, but the main thing is to look at the this bar at the bottom, which says basically between the carbon which is drawn out of the atmosphere through, say, growing trees, versus the emissions from human activities, what's the net effect in 2050? And you can see here, under business as usual with no adjustments to the economy, we're getting a 40% increase, which is not great. The task is essentially to get to net zero by 2050, though now we have the Zero Carbon Act. Methane emissions have a different target to other emissions. So what that means exactly for this calculator, we won't go into too much right now. Well, let's just aim for net zero by 2050. Of course, you can aim for other levels of emissions if you want. But yeah, for this exercise, we're going to go to net zero in 2050. So basically all the purple and the yellow, when there's yellow, cancels out the other colors and the net effect is zero. And you do this by adjusting these levers for different parts of the economy here: electricity supply, all these different areas of activities, and you can go into them and see the separate activities you might undertake to reduce emissions, and they all have different settings. So over on the left, it's basically do nothing. Over on the right, it's really pushing the boat out and doing quite a lot. So maximum effort, essentially. So I've already prepared some scenarios. Actually, I'll just show you here what the effect of changing something is. If we just pull this lever across to maximum for grid electricity, you can see how the main graph in the middle went down as I adjusted that lever. Because what we're saying is in 2050, the emissions from electricity are far lower because we have far more renewable energy. So what I've done is gone through and already adjusted some of those levers to develop a scenario. So here's my first one. This is one where I've just changed the type of energy that we're using to power things. So basically more renewable electricity and more bioenergy and more electric cars and things that use bioenergy. Essentially, I haven't tried to constrain growth and I haven't tried to make things more efficient. And you can see that over here with these little grey bars showing kind of maximum effort around energy supply. In land transport here, I haven't done anything to improve mode share or vehicle occupancy or anything like that, but I have electrified light vehicles. Oh, and we might as well electrify public transport as well. As you can see, they added an extra percentage point on. Okay, so the net effect of doing that, which is a very technocratic approach, just technology change, not trying to conserve anything, just use different type of energy, and also no change to land use. we've managed to achieve a 46% reduction in CO2. So that's not net zero, but it's pretty significant. But it tells us that just doing those things on their own is probably not going to be enough. So let's try a completely different approach. Here is a scenario where we haven't really changed our energy type, the type that we're using, or tried to change the type of technology per se. We've just tried to make it more efficient. So you'll see that in energy supply, I've actually put grid electricity across quite a long way because that's actually more realistic. These levels over here on the left are probably sub business as usual. We're on track to do a lot better than that. So this has got an electricity mix of 90% renewables, going up to a reasonably clean grid factor, which I consider to be business as usual. We're also using biofuel here. Oh, sorry, no, that's not true. So waste volumes have gone down, so that's a conservation measure. And land transport, we're doing all the right things in terms of reducing the number of trips, changing the mode, getting more people into vehicles, and we've improved efficiency as well. And here there's a few other adjustments which are to do with conservation. And you can see the effect of that is an 11% decrease. So that's not enough either. So simply using conservation and efficiency is not going to do it. Alright, so let's try a third scenario. Now this is one where we've exclusively focused on what we could do in the land use sector and haven't done anything to the energy side of things or the waste side of things. So we've got maximal land use change away from sheep and beef. We've focused on 1/3 natives, which implies 2/3 exotics with the types of trees we're planting on that land. We've reduced stocking rates. We've reduced the intensity of land use. And we've also used things like nitrogen inhibitors. So doing all those things together has resulted in a 55% decrease in emissions. So pretty impressive for one area to do that all on its own, but still not enough. None of those things have actually gotten us to 2050. So now you might be wondering, all right, well, is it actually possible to get to net zero by 2050 using this calculator at all? And the answer is yes, you can. So basically, if we dial everything up to maximum, you can see all the grey bars are basically all the way across. Trust me, they're set to maximum in all cases, you can see here, except one in agriculture and forestry. This one here is set to this is set to what looks like the lowest setting, but actually gives the highest emissions reduction because it's the one that controls the type of forest. And exotic plantation forest sequesters more carbon per hectare than natives. So if we go through to full natives, you can see now, that purple shrunk right back, and the reduction has gone from 160 something down to 126. So this represents the maximum we can get out of the calculator here. If all those trees are exotics, then you can get 162% reduction compared to the baseline. So we've actually gone carbon negative, significantly carbon negative. Okay, but that combination of activities might not be desirable. You know, that's really throwing everything in the kitchen sink in. It's doing things which, you know, it implies we have some choices. If our target is to reduce by 100% by 2050 and we've got 162, well, that's great. We're helping out. We've got a safety margin, but we might have been forced to make some unpleasant or difficult choices, and there are some choices available to us. So let's explore what some of those choices are. Here's a scenario here where I've managed to get 102% decrease. It is a scenario where where we haven't done the absolute maximum on renewables. You can see solar panels for hot water don't actually have any impact. If we set that to maximum here, you can't see any difference. So why don't we not bother doing those solar panels, since it makes no difference. That's solar hot water, by the way, not solar PV. Over here in land use change, yeah, we've eased off a bit on the amount of land put into forest, and we've said that 1/3 of it is native rather than it all being exotic. And also we're not relying particularly heavily on new technology to reduce the emissions from animals, because those technologies may not deliver. We don't know that yet. We've done everything we can on buildings. We've gone pretty extreme on what we can do with aviation and freight. On land transport, we've gone hard for electrification and mode share, those sorts of things, but we haven't done everything. Okay. And here's another scenario. It's a variant on the one you've just seen. But in this one, you can see that here in agriculture and forestry, we've said, well, actually, we don't want exotics at all. We want it all to be permanent native forest for various reasons. You know, that might be for biodiversity reasons, or that the emissions are better held in that type of forest in the long term. So what other things have we needed to do in order to achieve that, given that there is a trade-off, given that native forest won't store as much carbon? Well, we've had to go very hard on grid electricity here, and pretty hard on, harder anyway, on passenger land transport, and basically needed to constrain demand a bit in some areas in order to make up for that shortfall. Another thing that I should show you before we get too much further is over here on the left, we've got other versions of the graph. We've just been looking at the emissions graph. There's also an energy graph if you're interested in what's happening to different types of energy use, and where the energy is coming from, the different types of power plant. And above it, possibly more interestingly, we can set it to other areas within the Wellington region. So what we've been looking at is the total combined regional emissions, but if we look at just the Kapiti Coast, for example, you can see it looks quite a lot different. There's the land use and forestry sector plays a much smaller role, and the other types of emissions, basically energy use, loom a lot larger. So you can see in that it's the same scenario I was showing you before with 100% reduction, but in Kapiti Coast exclusively, if we just look at that area within that scenario, that's produced 78% reduction. So where's the shortfall getting made up? Well, it's getting made up in the Wairarapa. So if we flick over to the Wairarapa, we can see that the Wairarapa as an area has achieved 192% decrease. So basically all these extra trees are soaking up emissions from other parts of the region. And that's not just Kapiti, that's also Wellington City as well. As you can see, unsurprisingly in the Wellington City area, land use, forestry and agriculture play a very small role, and there's a huge chunk here which is fuel combustion, which is vehicles, and also basically all energy use. So yes, so when we're looking at the different scenarios that you might come up with, it's interesting to look at what the implications are for individual districts. Anyway, I encourage you to play around, come up with your scenarios that suit you, and make a note of what the settings are and what it looks like. And then once you've finished, you can click share your scenario, and that can go straight to social media if you like, or you can simply copy the link and save it somewhere, and that will take you straight back to your scenario whenever you paste that into the navigation bar of your browser. So that's how I've gotten between all these scenarios here. I did them earlier, I saved the link, and then I was able to bring them up on a new tab just like that. So I hope that was useful. If you have any questions, please contact us at the address below. Thanks.